All right, hello and welcome. This is going to be our help video for the homework titled Rationals Quiz Review and Operations on Rationals. The first 10 questions of the review are for the quiz. Everything else is just normal homework. So we'll get started with some of that review for the quiz. This will be our key. We started with graphing some equations, and it's easy to see that this is just transformations on the graph of y equals 1 over x. Now, what transformations have happened? We've got a k value of 2. That means we are shifting this up 2. An h value of 3, so we're going to go right 3. And an a value of 2, so we're going to stretch 2. All right, first thing I like to do is add in my asymptotes. In the parent function, they're normally located at y equals 0 and x equals 0. Now they've been shifted. The one that's horizontal has been shifted up 2, and the one that is vertical has been shifted to the right 3. Just like that. Drop this one down just a little bit. Well, maybe it's got to stay there. Oh well. All right, so we've applied those shifts. The next thing we know is that this is going to be stretched 2. Normally, to get our points in our parent function, we go to where the two asymptotes intersect, and we go up 1 over 1. But now it's been stretched 2, so we're going to go up 1 over 2, or, because it's symmetrical, up 2 over 1. And let's get our other two lattice points. Backwards 2, down 1, down 2, backwards 1. And those are the only lattice points we're going to hit. We'll connect them with a line that flattens out to these asymptotes as it extends off of the graph. So it's going to look a little bit like that. This one here, number 2, has been flipped. So if I added my asymptotes, I should have one at -1 and one at -3 because of the h and the k values. Now, instead of filling into corners 1 and 3, I'm going to fill into corners 2 and 4. Vertical stretch of 2 means that we should go over 1, up 2, in all directions, make it symmetrical, and connect these up the line that then lies flat to the asymptote. All right. Moving on, identify all the vertical asymptotes of each, right? The equation for the line is x equals a value. So in order to do this, we need to factor. I just want to do one of these, so I guess I'll pick this first one. Looks maybe slightly harder to factor. The top's going to be two numbers that multiply to be 3 but add to be 4, going to be 3 and 1. X plus 3, x plus 1. On the bottom, I can take out, I'm going to take out a -2 first, leaving behind an x squared minus x minus 6. And then I'm going to rewrite that as x plus 3, x plus 1, divided by -2. Two numbers that multiply to be -6 but add to be -1 are going to be -3 and +2. So x minus 3, x plus 2. So I look and see if any of my factors are going to cancel out. None of them do. So my vertical asymptotes are the values that make the denominator equal to 0 and don't cancel out. So our vertical asymptotes are going to be at x equals 3. That's the value that would make this 0. And x equals -2. Let's look at 5 and 6 here. Identify the x value of the wholes of each function. Let's do the second one since we have to do slightly different factoring. In the top, I'm able to pull out a 2, leaving behind an x minus 4. And the bottom is going to be x plus 4 times x minus 4. Those are two numbers that multiply to be negative 16 but add up to be 0. There's no b term. These are also called conjugates. These factors cancel out, and it's the factors that cancel that cause holes in the function. So the hole is at the value that would have made that 0. So we've got a hole at x equals 4. 4 is the value that would have made that 0. And although the question doesn't ask for it, we have a vertical asymptote at x equals negative 4. All right, identify the points of discontinuity. Excluded values for each, right, with a does not equal symbol. So this is going to be both holes and vertical asymptotes. We're going to have to factor just the bottom of these. Both of them look pretty easy to factor. I guess I'll do number 2 here. This is going to factor into x minus 3 and x minus 2. Right, that way they add up to negative 5, multiplied to be positive 6. And so I know that x does not equal 3 and x does not equal 2. Just take the opposite values and we're done. Those are our points of discontinuity. If we want to figure out if they're holes or vertical asymptotes, you got to factor at the top and see what cancels. All right, on to just the regular homework. Graph the function, draw a dotted line for the vertical asymptote, draw a dotted line for the slant asymptote, and write the equation of its slant asymptote in y equals mx plus b form. First, let's cover why we can tell both of these are going to have a slant asymptote. It's because in both of them, the degree on the top is a 2 and the degree on the bottom is a 1. The biggest exponent would be a 1 here if I had to fill something in. And if the top is 1 bigger than the bottom, it will automatically have a slant asymptote. In order to graph this, I'm going to want to factor these to help me identify some of the features. Let's say two numbers that multiply to be negative 3 but add to be negative 2, negative 3 and positive 1. In the bottom here, I can factor in a negative 3, leaving behind an x minus 2. So no holes in this one. These values here tell me that I've got x-intercepts at 3 and negative 1, because those are the values that would make these equal to 0, thus making the whole thing equal to 0. So let's add that to the graph. We'll dot at 3, dot at negative 1. I've got a, let's do this in green, vertical asymptote at x equals 2, because 2 is the value that would make the bottom here equal to 0. Because it doesn't cancel out, it's a vertical asymptote. So I'm adding a dotted line for x equals 2. Now to find the slant asymptote, I'm going to go back to the standard form and do some long division. So negative 3x plus 6 outside of x squared minus 2x minus 3. I ask myself, what do I have to multiply negative 3x by to get an x squared? What's going to be negative 1/3 x? Let's actually do the multiplication. I get an x squared. I get a negative 2x. Subtract it away. And we get a 0. So it's just y equals negative 1/3 x for our slant asymptote. All right, so let's add in a dotted line for that. I'll add it in this red color. Down 1 over 3, down 1 over 3, down 1 over 3, up 1 backwards 3. There's the slant asymptote. Now, if you look at the x-intercepts, there's only one way to curve in here. and that's to lie flat here, hit that intercept, and then lie flat here. Go down to negative infinity, reappear at positive infinity, hit this intercept, and lie flat to the slant asymptote as we leave the graph. All right, and so that pink line is a pretty good representation of what this graph is going to look like. Let me just check the answer key to make sure I didn't make it look too different. Yes, that looks, if you look at that, you look at mine, pretty similar. I like to see the dotted lines because that's how I know you knew what you were doing when you graphed this. All right, just make sure this video is working. That looks right. It's good to double check. Okay, so now we've got a bunch of operations with fractions, or with rational functions. The hint on all of these is factor everything first. So factor first, always. Look for a way to simplify. So in like number 1 here, I see that I can take a 9 out of all of these. So 9 times k plus 1 divided by 9 times 9 over actually see I can pull a 9 out of these as well. Why don't I do that instead of pulling out the 27, make it 9 times 3k plus 3. And that way these 9s will cancel, these 9s will cancel. And what I'm left with is k plus 1 divided by 3k plus 3. Now I could factor in a k plus 1 from the top and the bottom. Cancel that out. So k plus 1 over 3 times k plus 1. And these cancel, and I'm left with just 1/3. That's for number 11. Number 11, let's just double check, we get 1/3, yeah. So by canceling, factoring and canceling, we saved a lot of work versus distributing across the top and the bottom and then looking for ways to cancel. All right, 13, 14, I guess 14 maybe looks a little more challenging. I'll do that one. We have to, excuse me, divide. Let's factor everything that we can. We've got 7 times n plus 1 divided by n minus 7. I'm going to flip, I'm going to do copy dot flop, bring this n plus 8 up to the top. Then on the bottom, that's going to become n plus 8, n plus 1. And I see lots of things that would cancel. The n plus 8s will cancel, the n plus 1s will cancel. I'm going to be left with 7 over n minus 7. 7 minus 7 over n minus 7. Yep. All right, addition. So here we're getting slightly trickier things. But first off, don't miss an opportunity to still simplify even when we're doing addition. These 3s can cancel, these 6 can cancel, and I'm left with 1 over x plus x. And I'll write my x like this because I have to make it match. So to make the denominators match, I've got to multiply this by a form of 1. I'm going to multiply it by x over x, therefore getting an x squared over x. Now that the bottoms match, I can add across the top, and I'm going to get x squared plus 1 all over x. Let's take a look at maybe one of these bigger divide ones, like number 18. To get these denominators to match is quite a bit more difficult. I'm going to have to multiply them both by each other's denominator. So for the 5 over n minus 2, I'm going to have to multiply that by n minus 4 over n minus 4. Let me clear some of this out. And on the other side, I'll have to multiply by n minus 2 over n minus 2. Now the rule is you leave the denominator factored, but you simplify the top halves. So this is now going to be equal to 5n minus 20 after I distribute that 5, all in parentheses, minus 3n squared minus 6n, all in parentheses, but keep the bottom factor. Don't FOIL this. Just leave it as n minus 4, n minus 2. Let's combine like terms on the top, see what we get. We're going to get negative 3n squared, 5n minus, so plus 6n plus 11n minus 20, all divided by n minus 7, n minus 2. So we're going to leave our answer like that. Let's see how that compares with the correct answer. Make sure at least on the right track. Yep, just in a very different order in the answer key, but I like my order better here. It looks more like standard form. Okay, 19 and 20 are what we call complex fractions. One technique is to get everything in the terms of the same denominator. The other technique is to just add them one piece at a time. And I like doing it just the one piece at a time method. So I'm going to multiply this by 8 over 8. So now I've got 4x over 8x squared over 16 minus x squared over 16. This here is going to become 4x over, and it's very important to keep track of which fraction sign is bigger. So this is 4x being divided by the quantity 7x squared over 16. Now we can copy dot flop this. I'll get 4x over 1 times 16 over 7x squared. One of those x's can cancel, and we'll get, what is that? 64 over 7x. 64 over 7x for 19. 64 over 7x. All right, so I combined the fractions on the bottom before copy.flopping to combine the whole thing. All right, these last two look like they could be kind of lengthy problems. I guess I'll do number 22. Looks like a beast. Let's see, first thing I can do is I can factor in a 3 from all of these. So 3's all cancel, leaving a 1 behind, and this is going to become a negative 20. All right, I can factor in an m as well, so this is going to be 1 over m times m squared plus m minus 20 plus 5/3. Let's see, I'm going to keep factoring. 1 over m, two numbers that multiply to be negative 20 but add to be positive 1 are going to be 5 and negative 4. Plus 5/3. All right, now to get this to have a common denominator, I got to multiply by a lot of stuff. I got to multiply this by m plus 5, m minus 4, all divided by m plus 5, m minus 4. And I have to multiply this side by 3 over 3. All right, now that my denominators match, They'll have the same parts, just in different orders. I can just add the numerators. So I get 3 plus 5 times m times m minus 5, m plus 5, m minus 4. Across the bottom, 3m, m plus 5, m minus 4. The numerator can definitely be simplified. I know that this is equal to m squared plus m minus 20. So let's write that. Five m times m squared plus m minus 20 at, I'm pretty close to my final answer here. So 3 plus 5m cubed plus 5m squared minus 100m, all divided by 3m, m plus 5, m minus 4. Let's see how that compares to the actual answer key. It looks to be about the same. 5, 100. Yep, that looks to be about the same. All right, so hopefully this has been helpful. I'll see you in class.